Hello, today we'll discuss the superposition theorem. Superposition theorem, it states that in a network, in any network, containing more than one source, the current in or the potential difference across or the potential difference across any branch can be found by considering each source separately by considering each source separately and adding their effects omitted sources of EMF are replaced by resistances equal to their internal resistances. This is the statement of the superposition theorem. Okay, so it states that in any network containing more than one source, suppose one network is there and there is a suppose two sources are there, then the current in any branch or the potential difference across any branch can be found by considering each source separately. Means we have to consider each source separately. If there are two sources are there, we have to replace one source by its internal resistance for time being and find the current or potential difference across the any branch. And this is first step. Second step, now we have to replace the first source and we have to active the second source. So by acting by activation of the second source and again the omit of the first source, again find the potential difference and currents in any branch, and then we have to add their effects. Finally we have to add the why we have to add, because we have to find the current flowing through any branch or the potential difference when both the sources are acting. Okay, so that is the addition of their effects when both the sources are acting. But when solving these examples, we have to consider only one voltage source at one time and replacing the other source by its internal resistance. And next steps, omit the first source and again active the second source. In this way, we have to find the current flowing or the potential difference across any branch. And now we'll consider one example so that we'll get the idea uh, how to solve the examples by using the superposition theorem. So by using superposition theorem, we have to calculate the current in the network. Calculate the current in the network by using superposition theorem. Okay. So the network is given like this. We have the network is like this. We have this resistance first, and there is one voltage source is there. Then there is a second branch having this resistance, and there is no EMF source in this branch. And there is one more branch having this resistance, but there is one source in this branch. So this there are more than one source. That means we have to apply here superposition principle. Okay, this is voltage is given 20. This is a 1 ohm resistor. This is a 18 ohm resistor, and this is a 2 ohm resistors. And now the current flowing through this is I1, this is I2, and here this is the addition of current I1 and I2. So this is the network, and this current is flowing through this branch I1, and current flowing through this branch is I2 when both the voltage sources are acting. And this is the addition of the currents when both the sources are acting. But now we have to find this current flowing through this branch when by applying the superposition theorem. And this superposition theorem states that the in any network containing more than one source. So now this is one source, this is one source. So there are two sources. Okay. Therefore, the current in or the potential difference across any branch can be found by considering each source separately. So we will consider first this source and replace this source by its internal resistance if any. If there is no internal resistance, we'll just short this voltage source. And at second time, we will apply this voltage source and we will short this first voltage source. So uh, every time we have to consider only one voltage source, and we have to find the current flowing through the networks. So now we will consider this voltage source, and we can replace this voltage source by the. So there are two voltage sources in the network. The two separate networks can be considered. Okay, so first network we'll consider. This is a 1 ohm, this is 18 ohm, this is 2 ohm. Okay, and this is a 10 volt. Now we are considering here only one voltage source. So this current now we'll consider this is I1 dash, and this is we'll consider as I2 dash. Okay, but now we have to calculate as there is only one. So calculate the equivalent resistance. Equivalent resistance is nothing but these two are in parallel, and these two resistance are in parallel. We'll get one resistance that will be in series with this resistance. So therefore total resistance will be 1 plus 18, which is in parallel with 2. Therefore we can do like this. So this is the resistance. If you find this 1 plus, so this is coming equal to 2.8 ohm. So we have got this total resistance of the circuit. Now we'll calculate this I1 dash. So I1 dash is equal to this voltage source 10 divided by the total resistance of the circuit 2.8. So we have got here 3.57 ampere. Okay. Now we have got this I1 dash. Now we have to find I2 dash. Just by current division methods we can find I2 dash. So I2 dash is equal to this current I1 dash into, we have to find the current flowing through this, so we have to take the resistance of opposite branch divided by the opposite branch plus the same branch. So I1 dash we have got here 3.57 into 18 by 20, and this is coming equal to, here coming equal to 3.21 ampere. And now I2 dash, what is the sign of this current? Actually it is a minus sign. It is a minus sign because when the circuit was, when the both the sources are acting, the current direction is like this, but now this source is acting, therefore direction should be from left to right, left to right. That's why its sign is now negative. Okay, so now we have to find the total current here. This total current is I1 dash plus I2 dash. So I1 dash plus I2 dash is equal to, I1 dash we have got 3.57 plus I2 dash is minus 3.21. So here we have got minus 0.35 ampere. Okay. So now this network we have considered when the first source was acting. Now we'll consider the second voltage source. When you consider the second voltage source, the network will be like this. This is 1 ohm, this is 18 ohm, this is 2 ohm, and this is the voltage source. Second voltage source value is 2, and this is the, here this is a I2 double dash, I1 double dash. Here it is a I1 double dash plus I2 double dash. In previous case, when this source was acting, we have considered I1 dash, I2 dash. Now we will consider it as this second source is acting. Now we will consider this I1 double dash, I2 double dash. Now again we have to find the equivalent resistance of the circuit. Now we have to find from this is a voltage source we are considering. Therefore now the equivalent resistance, these two are in parallel. So 1 into 18 divided by 1 plus 18, and this will be in series with 2 ohm resistor. So therefore 18 by 19 plus 2, this is coming equal to 2.95 ohm. So this is the resistance, equivalent resistance of this circuit. Okay, now we have got equivalent resistance. Now we can find this current I2 dash. I2 double dash is equal to this voltage upon resistance. This voltage is 20, resistance is 2.95. So this is coming 6.78. So this is a 6.78 ampere. Now we have to find this I1 double dash by the current division method. I1 double dash is equal to I2 double dash into, we have to find the current flowing through this branch, therefore take the opposite resistance divided by the opposite resistance plus the self resistance. So I2 double dash is 6.78 into 18 by 19, and if you find this is coming equal to 6.42 ampere. Now see, the direction is opposite to the conventional sign of the current. That's why we have to take here negative sign. Here we are not taking here negative sign because the direction of the second direction of the current when the second source we are considering and the conventional current is same. That's why this is we have taken positive. But here I1 double dash, the direction of current is from left to right, that is a conventional direction, but here current is flowing from right to left. That's why we are taking here negative sign. Okay, now we have to calculate this current, I1 double dash plus I2 double dash. So I1 double dash plus I2 double dash is equal to minus 6.42 plus 6.78. This is coming equal to 0.36 ampere. Okay, 0.36 ampere. And now we have to consider, we have to calculate the current I1. What is I1? I1 is nothing but I1 dash plus I1 double dash. When this is the current when first source is acting, this is the current when second source is acting. So what is I1 dash? I1 dash we have got here. I1 dash is 3.57. 3.57. And what is I1 double dash? This is I1 double dash. I1 double dash is minus 6.42. Okay. So this current is coming minus 2.85 ampere. So this is I1. Similarly, we have to find I2. I2 dash plus I2 double dash. So I2 dash we have got here. I2 dash I2 dash is minus 3.21. Minus 3.21, and I2 double dash just we have got here. It is a 6.78. So this value is coming 3.57 ampere. So this is the current flowing through the branch I1 and I2, and on the middle branch the current flowing through is the addition of I1 plus I2, which is equal to minus 2.85 plus 3.57, and this is equal to 0.72 ampere. So in this way we can find the current in or potential difference across any branch by using the superposition principle. Thanks to you very much for watching the video.